and I start the game, you can see my archway is still there. Hello and welcome to part 24 of the How to Code a Game Like Minecraft in Unity series. Yes, this was supposed to be the cross-trunk lighting video, but the more I worked on it, the more it became clear that forcing it to work in the way that would work with this project was set up was just going to cause more problems, and it was snowballing essentially. So we're going to fix some of my issues with the make it up as I go along approach, and that led to me creating the loading and saving system by accident. Well, not by accident, I sort of knew the way it was going to go, but the way that I was going to make the lighting system work ended up with me doing like 90% of the work that I needed to do for the loading and saving system. So that's what this video is going to be about, and then when we do the cross-trunk lighting video, it's going to be a lot easier because we'll have done a lot of the work in this video. Basically, the first thing we need to do is we need to look at how we load and save our world data, because right now we generate voxels on request, and then we have a second pass for structures, which we call voxel mods, and then those get applied after the fact. And the truth is, except for players modifying blocks, there's no mad rush to update chunks, so we can take our time, we can make sure everything is generated, and then we can start creating the chunks afterwards. So to start with, we're going to create a new variable in our settings class to tell us how large an area we want to load data for. So the data is going to be behind the scenes, and then basically we can load that data as much as we want without affecting the game, and then when we want to create a chunk, instead of checking neighbors and generating new voxels, we just dip into that data, pull out the information we need, and create the chunk from it. So this is going to work like view distance, except it's going to be all behind the scenes and in memory, and when it's not going to be tied to a mesh or anything like that. So we need it to be a decent amount bigger than view distance, because we're going to remove some null checks when we're creating new chunks, because basically the load distance will be a decent enough border around the view distance so that whenever we are loading up a chunk, we don't need to worry about whether the data's there. So that's the whole idea, is that the load distance will always be bigger than the view distance, and then we can just grab the data from it without worrying about if it's being generated. So if we go into our scripts, and we are going to find our world class, and then somewhere down the bottom we have our settings, and I'm just going to stick it here. So public int load distance, and it's going to equal, I'm going to set the default to be twice as big as the default view distance, although I'm going to change both of these settings in the actual settings file just for the sake of speed, because I don't want to have to sit waiting for the game to load every time I run it to test something while I'm recording a video for you guys. So we'll just save that and run back into our project, and if we find our scenes folder, open up our main menu, and there's no option for it in the settings yet, but we just want to open the settings menu, close the settings menu, finish playing the game, and then that should have saved our new variable. There we go, load distance. So I'm just going to set these super small for now, because like I say, I'm going to be loading the game a lot. So I'm just going to set load distance to 4 and view distance to 2. And then we can go back into our main scene. Now we need a new class for storing our world data. We'll create a new script for this, and we're going to call it world data. And we're going to put it in a new folder called scripts/data, because I just want to try and keep things tidy a bit. We're going to be doing a lot of tidying up from this point on in future videos and stuff. It's all going to start to get a little bit more tidy and neater and organized, because the one thing this cross-trunk lighting video has taught me is that I can't carry on with a project this big and this complicated with the make it up as I go along approach. So I've been sort of planning ahead a bit more now. You may find that I do things that don't immediately become obvious why I'm doing them in that particular video, but it may become apparent later on. So let's go into the scripts folder. Let's create the new folder that I just mentioned, which we're just going to call data, and then in our data folder we're going to create a new script which we're going to call world data. Let's open that up. So this isn't going to be a mono behavior script, it's just going to be a data class, and it needs to be serializable, because we are going to save this class. This is going to be the class that actually gets saved. This is why we're creating a separate class to our world class. So this class needs to be serializable, and it also needs to have as little in it as possible. Like, we only want to put things in here that we want to save. So the first thing we're going to want to save is a public string world name, which for now I'm going to say equals prototype. We'll get to setting the name and well, not setting the name, but we'll get to passing a name into the world later on in the video. And then the seed. And that's really the only information at this stage in our project. That's really the only information we have for the world. The rest of it is just chunk data, which obviously is the important part, but we'll get to that. So before we can do any more with that class, we're going to need that chunk data class. So we'll put that in its own script and throw that in the data folder as well. So go back to Unity, wait for it to catch up. new script, chunk data. And this is the same situation as our world data. This is going to represent the chunk purely on a data level, and it's going to be what we actually save when we save it. So we can delete all the start, delete the mono behavior, make it system.serializable. From what I just said about saving it, we need to keep the position of the chunk, like the X and Y position of the chunk. And if you've modified your project to do vertical chunks as well, up and down, then you need to keep the X, Y, and Z. So we're going to be saving them as X and as Y, but we want to be able to access them as a vector2 int because it just makes it easier with the rest of the code that we've got. Now the reason we can't just store it as a vector2 int is because vector2 ints are not serializable, so we can't save them the way that we're going to save them. I mean, obviously we could do stuff to make it savable, but we're not going to do that. We're just going to create a public vector2 int called position, and it's just going to be a get setter, and the get is going to return a new vector2 int X and Y, and the set is obviously going to do the reverse. X equals value.x, Y equals value.y. As you can see, these two values are not public, so they're not going to be visible from the outside. The only thing that's going to be visible is this vector2 int, but this vector2 int is not a proper value. It's just basically we're just using it as an accessor to get to these values, and it represents itself as a vector2 int. But when we save the data, we're going to be saving this, which we can save. Ints are serializable. We can save an int, we can't save a vector2 int, or at least not in the method that we're going to be doing it. And then below that we need another value, and this value we're going to put hide in inspector. Because we've serialized everything here, we're going to be serializing voxel state if we haven't already. In fact, I'll just check that. Going to world, or is it in chunk? Actually, voxel state might be in chunk. Yeah, voxel state's in chunk. So we need to serialize this because we're going to be saving this as well. But the problem with this is that we're about to create a very large array. Well, no, it's 16 by 16 by 128 in my project. Obviously, your project may be slightly different. But the problem with this is that Unity is really not good at showing a lot of information in the inspector. And because we've serialized this field and we've serialized this field, it could try and show it in the inspector depending on what you're looking at. We don't want that, so we're going to say hide in inspector so that it doesn't try and show all that data during the game and basically just smash the editor. So that's going to equal a new voxel state and then voxel data dot chunk width, voxel data dot chunk height, voxel data dot chunk width again. And yes, this is exactly the same as the voxel map that we currently have in our chunk class. We will be addressing that shortly. That will be going away, and we'll just be using this one. So now we need to add a way to actually store chunks in our world data class now that we've got the chunk data class. So if we go back to our world data class, and what we're going to do is we're going to create a dictionary. So for the dictionary, we're just going to say public dictionary. Vector2 int is going to be the key. Chunk data is going to be the item that we're storing, the value. And we'll just call it chunks. It's going to equal a new dictionary vector2 int chunk data. And then we're going to create a function for requesting a chunk from that dictionary, which is just going to go like this. Public chunk data, and we're going to call it request chunk. We'll take in a vector2 int, which we'll just call chord now in sort of homage to our chunk chord class that we really didn't need to make because I didn't know about vector2 ints when I made this project at the start. But that's another thing that will be fixed in time. If chunk dot contains, if chunks, because that's the name of our list, dot contains key. So we're asking if this part here, which basically acts as the index, I mean, I've explained this in a few of the different videos, but I don't know if I've explained it in the Minecraft videos. If you don't know how a dictionary works, it treats this as kind of the accessor, the index to it, or the key, and then this is the data. So you don't have to have 0, 1, 2, 3, 4 like in a normal array or a list. This can be anything. You could have it as a string, you could have it as an int, you could have it as a vector3, whatever it is, and then when we try to access the dictionary, we pass in a vector2 int, and the dictionary sees if that vector2 int is in any of the key values, and if it is, it returns the chunk data that is associated with that key. So we're passing in this vector2 int here. We're saying if the dictionary contains a value for that key, then we want to return that one. So we access it the same way you'd access an array, only instead of passing in an index, we're passing in a vector2 int. So that will return the chunk that is associated with that key. And we're using the position of the chunk as the key. So basically, we don't need to worry about what it was called or what it was stored as. The position of the chunk is the key with which we access it in the dictionary. And then for now, we're just going to say else return null. So our request chunk function will return any data that's loaded or return null if it's not loaded, and then later on we'll add another step where it checks to see if we've requested a chunk that has been saved to the file, but we'll get to that. So now we need a way to populate that chunk data. Fortunately, we've basically written that code already in our chunk class, so let's just go and steal that. If we go into our chunk class and we cut the populate voxel function out, which is up here somewhere, there we go. So we can just cut this wholesale. Don't worry, I've got notes reminding me to clean up all the rough edges that I'm creating by cutting all these bits out. And then go back to our chunk data class, which I'm in now, and then just paste it there. So we're going to rename it populate because there's no voxel map here. For now, we're just going to delete these, and then we just want to replace voxel map with map. And because we've basically created an identical array, it's still a 3-dimensional array of voxel states. That's all we need to do. We just need to replace the map. So there's a few problems with this. The first one is, well, we don't have a voxel map, but we fixed that by renaming it map. And secondly, we haven't taken any steps to make sure that this value is definitely set before this code gets run. So if we somehow forget to set the values here, then this doesn't work. And then the final problem is that we have a reference to the world, which is no longer accessible because there is no reference to the world script in chunk data. So for the first problem, we are going to create 2 constructors, and these will make sure that this class, the chunk data class, can never be initialized without setting this value. So we'll just say chunk data, and then we'll take in a vector2 int, we'll just call it pos, and then we'll say position equals pos. And then we'll also have a second constructor which will let us, just for the sake of it, just let us pass in an x and a z, just in case that ever becomes handy. Chunk data int x. Now you know what, that needs to be underscore x because we don't want it to clash with these values up here. So int underscore x, int underscore z. We'll just keep it as y just so it's the same as everything else. And then we're going to say position equals new. Oh, we'll just say it directly. So x equals underscore x. Y equals underscore, wow, I'm having a terrible typing day today, y. So we can set it either with a vector2 int or with an x and a y value. So we're going to get a little bit creative with the world issue, so this world reference here. And what we're going to do with that is we're going to turn our world here into a singleton pattern rather than having references to it everywhere. So the way we do that is first off, we need to make, we'll start here, a private static world, which we're going to call underscore instance, and then we're going to make a public static world, capital I instance, which is going to be a get, and then it's going to return underscore instance. And then we need an awake function, and in awake, basically we're going to check if there is already a static world instance set, and if so, well, we don't want more than one, so we're just going to delete ourselves. And also we're going to replace this L here with a semicolon. So we'll say if underscore instance does not equal null and underscore instance does not equal this, that means that somehow we've ended up with a second world and this was not the first one. In that case, we just want to destroy this.game object. Because in that case, we already have a world object and it's already set as the instance, and well, we don't need a second one. Else set this to the instance. So what this allows us to do is to access the world script, the live monobehavior world script, using the world.instance tag. So if we can demonstrate this. If we go into chunk and we go up to the top here, somewhere we have, oh, sorry, we just delete this. We don't have a populate voxel function anymore. And somewhere up here, there we go. So we have this world reference here. So let's just get rid of that. That's obviously going to break a lot of things. So the first thing is we'll remove this from the constructor. We don't need that anymore. And then obviously that. And then what we're going to do is we are going to replace, which I'll just do find and replace because there's a lot of them. We're going to replace all mentions of world with world.instance. 16 occurrences. And there, now we can access the world script using this, and it all works the same way it did before. And I think that should have fixed everything. I don't think there's any... Yeah. So if we go into world, I think there's somewhat... Where else do we mention... Oh, there should be a couple of errors here because we deleted that world part of the constructor for chunk. So we just... All we need to do there is just delete the chunk that we're passing in. And then finally, this one. So now we've got a chunk data class. It can't be initialized without giving it a position, and it can populate its own data with a call from chunk.populate. So let's head back to world.cs and make use of this. So if we copy our generate world function, which I think is up here somewhere, there we go. So we'll just copy all of this and we'll just paste it back in right here, and we're going to call it load world. Now, load world is going to operate slightly differently. For the first, well, firstly, we don't need this. And secondly, instead of view distance, it's going to use load distance. So any instance of view distance in this function, we just change, and that's all of them. And the next change is that we're not doing any of this. Basically, all we're going to do in here is say world data. Oh, sorry, we haven't actually given ourselves a world data value yet, have we? No, we haven't. So we need to give ourselves a world data value, and this is going to be public because we are going to need to get at this from other places. So world data equals new world data. And if you remember, we gave ourselves a default value, so our world is going to initialize itself, our world data is going to initialize itself as prototype. And then we go back down to our load world function, and we're going to say world data dot load chunk, and don't worry, this is going to give an error because we haven't made this function yet, and it's going to pass in a new vector2 int and the x and the z value. So now if we go back to our world data, we want to create this load chunk. So this is going to be a public void load chunk, and all this is going to do is this is going to bring the chunk, like load the chunk into the world data memory. It's not returning a chunk in the world script here. We're not going to be doing anything with it, so this doesn't return anything. We're just telling it to load the chunk. So vector to int chord, and then in here we're going to say if chunks dot contains key chord return. Basically what that means is that if it is in the chunks list, we don't need to do anything. All we've done is ask it to load the chunk. If it's already in the list, the chunk is already loaded. Otherwise, chunks.add chord is the key, and new chunk data chord is the value. And then we want to say chunks chord dot populate. So if you remember, it populates itself. Did I not make that function public? Chunk data, I did not. So that wants to be public. Populate. So now if the chunk exists, is already in the chunks list, it doesn't do anything, just returns back and carries on. If it isn't in the list, it adds the chunk, adds a new chunk data to the list, and then tells that chunk data to populate itself. And now if we just go back into chunk data, I just remembered I never fixed this. So now we can reference the world with world.instance. And then to fix this error here, because we're trying to add, because position is now a vector2 int, we can just get rid of that, and then we're going to say x plus position dot x, and then z plus position dot z. Position dot y even, sorry, because vector2 ints are x and y, not x and z. So basically what you want to remember is that all of this is going to be going on sort of at non-critical times, like when we're loading the chunk data into the chunk world data lists and everything like that. That's going to happen either when the game is being loaded for the first time, so you expect a long load time when you're generating a new world and everything, so that's not important. Or it's going to be happening around the outside of where the world is loaded in the game. So it doesn't matter if it takes a bit longer, because it's not like we've gone, oh, we need a chunk there right now and we need to load the data for it. This is 2, 3, 4, 5, 6 chunks outside of where the actual world stops being drawn. So it doesn't matter if it takes a little bit longer, it just needs to do it quick enough that by the time the player has had time to walk those 6 chunks, it has loaded. So now we need to modify our voxel modification code in world.cs, because instead of adding modifications to specific chunk mods lists, we're going to directly add them to the chunk data map. Because like I say, we don't need to worry about whether the chunk has been generated and then we need to add to it after the fact. It's just data, so we can change it anytime, and by the time the chunk actually tries to pull the data out of that chunk data, it will have already been modified. So let's go back to our chunk data request chunk function, which is it chunk data? Sorry, world data. Let's go back to our world data dot request chunk function. I'm going to go to the top here, and we're going to create a chunk data C, and we're also going to pass in a bool here called create. And then instead of returning here, what we're going to do is we're going to say C equals chunks card, and then else if not create, return null like we did before, and then else. So this is if we have got no chunk here, and this is set to true. So basically we're saying we're requesting a chunk, but we have 2 ways to go about it. We can request a chunk and whatever may be, there is a chunk or there is no chunk, and we just carry on. Or we can say, I want this chunk. If it doesn't exist, create it, which is what this bool is telling us. So if the chunk exists, we set C to the chunk. If it doesn't exist and we don't want it to create, we don't want to return there. We want to say C equals null. And then finally, if it doesn't exist but we want it creating, we say load chunk card, and then we say C equals chunks card, and then we return. Now we're going to add some more stuff to world data to take in global vector3 and a byte value to set the value of that byte. So for this, we're going to keep the vector3 just because it makes it easier to work with the rest of the code. We're also going to steal isVoxel in world function from our normal world class and put it into our world data class, just to make it that easier to use as well. So isVoxel in world, let's find the actual function, grab that. I'm going to put that in, this wants to return C. So we're going to put that there. That doesn't need anything doing to it, it's just going to work the same way it did before. And then we're going to create a function for modifying a specific voxel, which is going to be a public void set voxel, and it's going to take in a vector3 pos and a byte value. So this is going to be the global position of the voxel in the world, not in the chunk or anything like that, and it's going to be the value that we want to set the voxel to. So first thing, if the voxel is outside of the world, just return. We don't need to do anything because it's outside of the world. And then the next thing we want to do is we want to find out the chunk card value of our chunk's position, and we do that by saying int x equals mathf dot floor to int pos.x divided by voxel data dot chunk width, and then we'll just copy that because it's mostly the same for y. It's going to be y or z, could be z instead. Let's go with z and z. So that's basically, so if you remember how this works, this gets us the sort of whole number position of a chunk, and then to get the actual real world position of the chunk, we just times the chunk width by this value. And I'm not sure how much this is going to affect the video going forward, but it appears that someone is driving a tractor around a field behind my recording studio. So hopefully it's not too drastic on the microphone. So x times equals voxel data dot chunk width, and then just do the same for z, and then chunk data chunk equals request chunk new vector2 int x and z, and then we're going to say true. If the chunk doesn't exist, we want to create it. And again, this is all in the data in the background, so I can't think of a situation where you'll be creating or modifying a voxel that is not in a chunk that is loaded in the viewed instance, but should it happen, this will create that chunk. Voxel mods, I suppose, voxel mods could sort of spread out into the area that's not yet created, and then vector3 int voxel equals new vector3 int pos.x minus x int pos.z minus z. And then finally we just want to say chunk.map voxel.x voxel.y voxel.z .id equals value. So whatever value we pass in here, if the chunk exists, it will pull up that chunk, and if it doesn't exist, it will create a new chunk. That's what that function does. So that's why we added the true value, but we can also request a chunk and just say it doesn't matter if it's not there, just give me a null value. And then over in world, we go to our apply modifications, which is not down the bottom, it's up the top somewhere. And apply modifications gets a heck of a lot simpler. Basically, we can delete most of this inside this queue here, and we're just going to replace it with world data dot set voxel, and then we're going to give the position and the ID, and we'll try spelling position correctly. And that's all we need to do for that now. Because before we were loading the chunks and then we were applying the voxels after the fact, we had to pass the modifications for that particular chunk to the chunk and then let it handle its own modifications when it was ready. Now, because we're all modifying the data before it ever sees an actual physical chunk, we can just add it straight to the data, and then at some point after the fact, the chunk is going to get around to looking at that data to draw itself, and when it does, the modifications will already be applied. So speaking of which, there is some unnecessary stuff in our voxel, in our chunk class, that we no longer need. So we don't need is voxel map populated, and we don't need, and they should have referenced that somewhere, we don't need is editable. We're going to be getting rid of that, so we may as well just delete that now. And we don't need this here, this little block of code, because we're not going to be applying voxel modifications in our chunk anymore, and because we're not using that, we don't need this list either, or queue, sorry. And another thing we don't need is this. We do not need our voxel map anymore. So if we delete this, we're going to have a whole lot of errors, but that's fine because we can just search and replace once more. This time we're going to be searching for voxel map, and we're going to be replacing it with chunk data dot map. We'll replace all those. So it's still getting an error, but that's because we haven't given this chunk a chunk data value yet. So let's do that. Chunk data, we'll just call it chunk data, and then we'll set that. Where do we want to set that? We'll set chunk data in our, oh, we have to set, right, okay, sorry, we need to give it the position. So we have to set it down here because we can't set it before we've actually been given a position, and the position is determined here. I suppose we could work it out again up here, but it doesn't really matter. So we'll just do it down here. Chunk data equals world dot instance dot world data dot request chunk, and then we're passing in a new vector2 int, and then we're going to say int position.x int position.z, and then we want to say true. If somehow we have got to a point where we are drawing a chunk that has not yet been loaded into the chunk data, we definitely want to create that chunk. So now you can see that all those errors have gone. We are now referencing our chunk data map rather than our voxel map. So if we go over to world, we've created a few errors here, mostly to do with is editable. So for here, we can just get rid of this entirely, because there is not going to be such a thing as whether a chunk is editable by now. Because we're doing all the data beforehand, if a chunk exists, that means it has reached a point where it is editable. And down here, we can actually get rid of quite a lot here. So we'll delete this, and we'll delete this. And because we're not doing the, basically what this was about was because we couldn't guarantee that the first chunk in the list, we only wanted to update one chunk at a time. Because we can't guarantee that the first chunk in the list was going to be ready to go, then we were skipping over that one if it wasn't ready and going to the next one, but keeping track of it. So basically this updated false was, as long as it was false, it would carry on looping until it found a chunk that was ready to go and it would update it. We're not going to be doing that anymore, so we don't need this. We don't need this loop. We don't need that. We'll just drag that back to there. We do still need the lock, of course. And get rid of update. And then for the index, we're just going to say 0. We're just going to grab the first item in the list, because now it doesn't matter. We don't need to check if it's editable, so that can just carry on as is. That makes that look a bit neater. Maybe not neater, but not quite as wordy. Now for the other two errors, these are a bit more complicated. Firstly, we want to go back to world data, and we're going to create an alternative to set voxel, which, as you may have been able to guess, is going to be called get voxel. So we'll say public voxel state get voxel. It's going to take in a position value, and basically we can just copy this and modify it because a lot of it is going to be similar. This here at the top, instead of just returning, is going to return null. And then, sorry, this error here has just made me realize that I missed a bracket off. And of course that means I missed it there as well. And then this down here, we're just going to say return chunk map voxel blah 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 blah, all that stuff. So it basically works the exact same way. So now we can go back to world, and where we have these errors here, we can just say, we can delete all this. For check for voxel, we're going to say voxel state voxel equals world data dot get voxel pos, and then we'll say if block types voxel.id.is solid, return true, else return false. And then even more simply for this one, we're just going to say return world data dot get voxel pos. And again, these, like, obviously this function isn't necessarily, we don't need this here, but we'll clean things up like that as we go. So to clean up a few more loose ends, when we deleted chunk.populate voxel map function, we actually removed a couple of necessary lines that now aren't there, and we need to put them back. So we don't need to wait for the voxel map to be populated anymore, so we can just put the lines that used to be at the bottom of chunk.populate voxel map, we can now just put them at the bottom of the init function. So in here, after this, we'll say lock world.instance.chunk update thread lock, and then inside there world.instance.chunks to update.add this, and then if world.instance.settings.enable animated chunks, then chunk object.add component chunk load animation. There, so we just do that automatically because we're requesting the chunk here and it's going to give us the chunk data, but all the data will already be populated. So before, this used to wait until we were populated. Once we get to this stage, it's already been populated unless something has gone wrong somewhere. So the next thing is our world data.request chunk is going to give us some issues with threading, because in this project, what doesn't give us issues with threading? So if we don't do something with it, we're going to get some problems there, but we don't want to lock it using the same lock that we are using here, because that will cause problems, because that lock is doing other things. So we're going to go back to world, and just under where we created that lock, we're going to create a new lock. So this one is public chunk update thread lock. We're going to say public object chunk list thread lock equals new object. And then if we go back to world data request chunk, which is up here, basically this whole if statement here wants to be inside that lock. So we'll just say lock world dot instance dot chunk list thread lock. So if we run this now, fingers crossed, we should find that nothing has changed. Yes. So it's exactly the same as it was, but we've changed all of the underlying structure, the way it loads its data and everything. So now that we've done all that, we can get to actually doing the loading and saving. So before I get into this, I just want to do a quick mention to Brackies. Not that Brackies needs any sort of mention from a channel like mine, but it was their load save video, which I will link in the description or in a card or something. It was their load save video that helped me realize that I was making all of this more complicated than it needed to be. And obviously, if you watch the load save video, you will probably recognize a little bit of their code in the load save function that we're going to use. So let's create a new script, which we're going to call save system. And we're going to open this up. And oh, you know what, actually, before we do that, before I forget, there is something else we need to do. So if we go into our world script and just find a spot where we can put something, we'll go under here. We're going to say public string app path. And then in awake, we'll do it after we've set the instance. We're going to say app path equals application.persistent data path. Now, what this is this provides you a location to save data in that is persistent, as it says. So in the case of Windows, this will be like your username, app data, local, roaming, whatever the name of the game. And it will always be the same regardless of where the game is installed. The reason we're doing this here is because this function here, or this variable, is not accessible unless you're on the main thread, and we're going to be trying to access it off the main thread, which causes problems. So what we're doing is we're creating a regular old string, and then when we run the game, we're loading in the application.persistent data path and setting the string, and then we're going to access this string instead. So that gets around the threading problems that this creates. So now we can go to our save system, and we can type a whole lot of stuff. So firstly, we're going to need using system.io, and then we're going to type using system.runtime.serialization.formatters.binary. Binary is the format that we're going to save our world and chunks and whatnot in. We'll get rid of mono behavior. This isn't a mono behavior, but it is going to be static because we want to be able to access it anywhere, and it's not going to, there's only going to be one instance of it. And then the first thing we're going to do is create our save world function. So it's going to be public static void save world. It's going to take in a world data, which we'll just call world, and then we're going to set our save location, which will be a string. And it's going to be called save path, and it's going to equal world.instance.apppath plus, and then we're going to say /saves. Obviously, all this is arbitrary. You can save yours where you want. You can call your folders what you want. This is just, I'm loosely keeping mine something like Minecraft, but at this point, I'm not sure what Minecraft does anymore because I haven't played the game in ages, and I certainly haven't looked at how the games are stored anymore. And then we're going to say world.worldName. And then just to make sure it is a folder, we need to finish things with a slash. So world.worldName in this case is going to be prototype because that's the only place we've set a world name, but we will change that in a little bit. And then we want to check if that path exists. So we say if not directory.exists, and we pass in save path, then we want to create that path. So then directory.create directory save path. So for now, we're just going to stick a little debug here. Taking this a little bit at a time. Saving plus world.worldName. So I will just quickly pull up the folder that it should be saving into. So this is the folder it should be saving into. So I'm just going to delete that now so we can see it in action, because that's there from me doing the test run of all this project. So to test it, we're going to go into world, and we're going to drop down to, where are we now? Update that. And then just below this, we're going to say if input.getKey down keycode.f1. I'm just picking F1 at random. It's not really important which key you pick. In fact, you wouldn't have just one key to save the game if you were doing it like Minecraft. And we're going to say save system.save world. And we're going to pass in the world data that we have here. So then if I come back to our game and I run this, and get the console up, and I press F1, it says saving prototype. And then if I go over to our folder, you can see we have a folder for how to code a game like Minecraft in Unity. And if I open that, we have a saves folder. And if I open that, we have a prototype folder. There's nothing in it because we haven't told it to put anything in it, but it's there. So yay. So let's carry on with the rest of that function. Just ignore this error, by the way. It just randomly pops up in whatever version of Unity I recently installed. So let's go back to our save system and finish this function off. So the next part of it is binary formatter. Formatter equals a new binary formatter. And then we need a file stream, and the file stream is we'll just call it stream equals new file stream save path, but then we need to actually give it a file on the end of that save path. So I'm just going to call it world.world, and then it's going to be file mode.create, and then that's going to create the file and put the file stream in it. And then finally we want to say formatter.serialize stream world, and then finally stream.close. So if we run that again now, and we press F1, we're going to find we've got a bit of a problem. You can see this error here. So what I was saying before about vector2int not being serializable, I wasn't lying. Now you may be wondering where the vector2int is, and the answer to that is in world data, this list. Now, fortunately, it's not a problem because we're going to be saving chunks individually. Each chunk is going to have its own file. So what that means is we don't need this list in our save file. So we can get around that by saying system.nonserialized, and then what that does is that removes this from the saving process. So now if we go back in and we try again, we should find that this time the save works because we're omitting that list from the save process. So click save in prototype. And then if I go back to our folder, prototype, world.world. And we'll just have to take it on faith that the details of the world are stored in there. So the next thing to do is to have our game check if a world already exists. So we're going to give it a name basically, and the first thing it's going to do is go look in the saves folder and say, does this world already exist in there? And if it does, we'll just load that world up. And if it doesn't, then we make a new one. The first thing we need to do with this is we need to make a constructor for our world data. Right now we don't have one. So down here, it's going to be nice and simple. Public world data string underscore world name and int underscore seed. And then it's just going to say world name equals underscore world name. Seed equals underscore seed. And then we want to go back to our save system. And we're going to create a new function for loading world. So again, public static world data this time, and it's going to be called load world, and it's going to take in a string world name, and it's going to take in an int for seed, but we're going to set this to equal 0. So what this means is we don't have to give it a seed. You could also put any other number there. If we don't give it a seed, then it's going to assume that seed is whatever this number is here, or we can pass a seed in. Either way works. So first off, string load path equals world dot instance dot app path plus / saves plus world name, and then finally a / to close. And then we're going to say again, if this time if file exists, file dot exists load path plus world dot world, because that's what we're calling it. If you change what you're calling your file here, you need to change it here as well. And then we're going to say if it says it does exist, then that means that the file exists and we're about to load from it. So let's just say that in the debugger so we know what's going on. We'll just say world name plus found loading for the ROM from save. Now we're just going to copy this here because it's almost the same. So instead of save path, it is load path, and instead of file mode.create, it is file mode.open, because we're opening a file this time. And then we're going to say world data world equals formatter.deserialize stream as world data. So that gets our world data out of that file, assuming the file exists, in which case if it didn't we wouldn't be here. Stream.close, and then we just simply return that world. However, if the file didn't exist, then we need to know what to do there. So we say if the file doesn't exist, debug.log world name not found, creating new world. And then we say world data world equals new world data world name and the seed, which again we could have passed in or we could have left alone. And then we want to say save world, because if we're creating a new world, we don't want to have to create it next time. And then instead of returning a loaded world, we return the new one that we created, which we have also just saved. Now this way of loading a world is going to give us a bit of a fault, because if you go over to world data, this here is initialized. However, when we create a new one from serialized data here, there's no list because we have omitted it from the save, which means it's not initialized in this. So what we need to do is we need to create a second constructor, public world data, and this one is just going to take in a world data, which we'll just call WD, and then it's going to say world name equals WD dot world name, and seed equals WD dot seed. Now, because we'll be going through this constructor now, that means that the list will be properly initialized here like it was before. So if we go back to save system, and the first one, so this one here, instead of returning world, we're going to return new world data and pass that world into it. So now go back to our world and go up to the top here, and where we declared this before, we can get rid of that part. So we're just declaring the world data, and then at the top of start we'll put it about there. We'll say world data equals save system dot load world, and then we'll say prototype, and then we'll test it again in a second with a different name. So you can see it says prototype found, loading from save, and I can save it again, although it doesn't do anything because the file's the same and nothing changes. However, if I change this to testing, doesn't really matter what we call it, this time it should say that it didn't find testing and it's creating a new one. There we go, testing not found, creating new world, and then it's saying that it's saving testing because we've told it to save a new world after it's created it. So we're getting there, but right now all we're storing is a world name and a seed, and we need a bit more information than that. So we're going to save our chunks inside of a folder in individual files for each chunk, and the reason we're going to do this is when we want to look for a chunk, if you remember in our, where is it, chunk, is it chunk data? No. In here, load chunk. What we're going to do is we're going to have a third option here. So first check it's going to do is the chunk already loaded and in our list? If it is, return that chunk. Then it's going to check if we've got this chunk saved on file. If the chunk is saved as a file, it's going to load the chunk from file and return that. And then finally, the last option is create a brand new chunk altogether. With that in mind, we can start off by copying our save world system, because we're basically going to be using most of it again. And we're going to call it save chunk, and it's going to take in chunk data, which we'll just call chunk, and string world name, because we need to know what the folder is going to be called. So at the very top, we're going to say string chunk name equals chunk dot position dot x plus hyphen plus chunk dot position dot z. Is it z? No, it's y plus y. And then for here, we've obviously got a save path instance dot app path plus saves plus, and then here we just need the world name because we're not passing in a world data script here. We're just passing in a string, and then at the end of it, we're going to say chunks. So this is going to put this in the saves folder, in a folder that is the name of the world, and then finally in a chunks folder, it's going to put a file in there. So we say if directory exists as before, create the directory if it doesn't, and then we're not going to debug here because there's going to be a lot of chunks and it's already going to slow the game down when it's saving, so we don't want to add to that by debugging. We'll be able to see if it's worked or not. And then for the binary format, keep that the same. For the stream, save path, and this time it's plus chunk name plus, and then we just need to give it a file extension. We don't need to give it a file extension, but I'm going to, and I'm just going to call it .chunk. And then at the end, chunk. So that function will save a chunk data class to file. We just need to use it now. So the first thing we're going to do is create a list to keep track of any chunks that have been modified, because we do not want to be saving every single chunk that is in the game every time the game saves. We only want to save chunks that have changed since the last time that the game was saved. The very first save is going to be all of the chunks because you need to at least save the world once. This is probably why Minecraft takes so long to boot up. So let's create a second list in our world data. We go up to here. And once again, this is going to be non-serialized because we don't want to save this. And it's going to be a public list, and it's just going to take chunk data, and we're going to call it modified chunks. And it's going to equal new list chunk data. And then we want a public void add to modified chunk list. And the reason we're going through this function rather than just adding it directly to the list itself is because this way we can check and see that it isn't already in the list to begin with. So if not modified chunks dot contains the chunk that we've passed in, then modified chunks dot add chunk. So we're only adding it to the list if it's not already in the list. So the first most obvious place that this is going to happen is down here somewhere, set voxel. So just below where we modify the chunk map data, we can say add to modified chunk list chunk. Because if this is being called, that means that this chunk has been modified. And then the other places that we're going to need to deal with this are chunk. And if we find edit voxel down here, we're modifying it here. So just below this, we're going to call world.instance.worldData, because this is the easiest way to access it at the minute. Dot add to modified chunk list. And then we just pass in the chunk data here. And then the final place, if we go back to chunk data, is when we populate it. So if we're populating, that means it's a new chunk, which means it's not being saved, because if it was saved already, we wouldn't be populating it, we'd be loading it from the save file. So at the end of populate data, we want to, once again, world.instance.worldData.add to modified chunk list, and we're just going to pass in this. Now to save it. So if we go to our save system and we want save world up here, yep. And we're going to say int, no, actually the first thing we're going to do is we're going to say list chunk data chunks equals new list chunk data, and then we're going to pass in world.modified chunks. And the reason we're doing this is because the save process is not quick, and there is no way that stuff won't happen in the time that it takes to save the world, and we do not want stuff getting modified in this list while we're using it. So the first thing we do is immediately copy the list into a new list and then clear the old list, and hopefully this way we don't mess with the list while it's being used and we don't lose any chunks through the cracks. So we copy it into a new list and we clear the old list, and then the next time world save is called, this list should hopefully be accurate. And then we're going to say int count equals naught for each chunk data chunk in chunks. Save system dot save chunk, and we're going to pass in the chunk and world dot world name. And then we're just going to increment count. And the only point for the count is just so we can keep track of how many chunks we've actually saved, which we will show here by saying debug.log count plus chunks saved. Now if we run this and we press F1, we should see that the game completely freezes up and we have a very painful wait. If I load up our folder here and load up testing, we can see we've got a chunks folder and we have a bunch of chunks all being created, which is good. What's not good is that the game completely froze up while we were saving those chunks, and you can see it says we've saved 34 chunks there. But if I press save again now, it says no chunks saved because none of them have been modified. And if I change a chunk, you can see one chunk saved because that one was modified, so it was added to the list. And then again, no chunk saved. So it all works, it's just painfully slow. Obviously that's not very useful for our game, so what we're going to do is we're going to try and thread it a little bit. So the first thing we want to do is we're going to rip out this bit of code we've just created here up to there, and we're going to put it in its own function. Public static void save chunks. I'm going to take in world data world, and everything can stay more or less as it is, I think. And then we're going to go back up to here, and we're going to say, instead of running this code exactly, oh sorry, before we do this, we're going to need to add threading. So using system.threading, I'll say thread equals new thread save chunks world, and then we just say thread.start. So let's just head back to our game, and remember, even because we haven't looked at loading any chunks yet, it's still going to think that all these chunks are brand new even though we've already saved them once, because we're not looking at the file, we're just looking at what's in the modified chunks list. But now if I click save, you can see it's saving, but the game is still running. I won't say well, but it's running as well as it ever did. So hopefully any second now it will say it's finished saving. It's only saving 34 chunks, so it shouldn't take that long. There we go, 34 chunks saved, but now it didn't grind the game to a complete halt. So now the last thing we need to do is to get it to load those chunks. So let's go back to our save system and let's copy our load world function once again, although this one's going to be getting more modified than the other function did. So load chunk, it's going to take in string world name, and it's going to take in a vector to int position. And if we just go up to save chunk, we can just steal this line here, because we're going to need that as well. Only instead of chunk.position, it is going to be just position. So that gets us the name that we will have saved it as, and then the path is going to be chunks to get to our chunks folder, but then we're going to say plus chunk name plus, and then the file extension. And again, if you change this here, you need to change this here or it won't work. So then we're going to say if file exists load path, although the full load path is already there, so we don't need that world.world on the end. We're not debugging, again, we don't want to slow anything down any more than it has to do. So if file exists, then file stream, load path, we don't need this part, we've got the full load path. File mode open, this wants to be chunk data, not world data. Chunk data, and then stream as chunk data, and then stream.close, and then finally we're going to return just chunk data. There's no else this time. All it's going to be is, sorry, I need to change this to chunk data as well. And then if we've got past here, in other words, it didn't exist, then instead of loading it, we're just going to return null. So finally, if we go to our world data.loadChunk function, and here where I've put this little placeholder, we can now say chunk data chunk equals save system dot load chunk world name, pass in the code, and then if chunk does not equal null, so if we've requested a chunk from the save system and we've got one back, then we just say chunks.add chord chunk. Chord is the key, chunk is the value, and then we return. If it does return null, if we've requested from the save system and there isn't a chunk there, then it returns null and we move on to the next step, which is this one here. So I've just noticed a little problem, as it wouldn't be one of my videos if there wasn't a little problem, but I've got chunks here and I've got chunk here. That's two different folder names. So I'll rename this to chunk. It'll probably be, you know what, actually, no, I'll make them chunks. They're both chunks. Right, so now if we run our game, first off we're going to find ourselves with an extra folder, so you know what, I'm just going to delete the old one. So I'll delete this chunks folder here. Doesn't matter to the game is just going to go looking for chunks. If it doesn't find chunks, it'll create chunks. So let's start the game. So if I press save now, we're going to save whatever it was, 34 chunks. Okay, now if I exit out and start the game again, we should see that it's going to be a bit slower to load because it's loading the chunks from file, but you wouldn't be watching this in a normal game anyway. It would load everything and then it would show you the world. But what should happen now is if I press save, you can see no chunks saved. And that's because as far as the game is concerned, none of these chunks are new. They're all being loaded. So let's just make a few little modifications to the world. Let's build a brick arch or something. Cower before my Minecraft building skills. So if I press save now, you can see we have saved how many chunks? 14 chunks. And the reason we've saved 14 chunks, by the way, is because we walked off a little bit and the view distance extended, so that loaded new chunks. So anyway, we've saved those 14 chunks. Now if I stop the game and I start the game, you can see my archway is still there. Slow as all hell, but it's still there. And yeah, the loading from file really is not fast. But what this would be, what you would do with this is you would have a larger area loaded to start with, and then you were only sort of loading new chunks in small numbers. Right now, our load distance is very close to our view distance, which kind of defies the point of having a load distance, but I just didn't want it to take ages loading and saving things. But yeah, as you can see, Archway is still there, and that's because it's been saved to file. And that is it. That is the loading and saving system. Yeah, thank you for sticking with me through this video. Of course, I now need to thank my amazing Patreons for their continued support. You're all super amazing. The Patreons that have plumped up for the higher tier and get themselves a special thank you by name, of course, are Neil Rankin, Reg Reed, Dave Maldine, or Maldine, Gabriel White, Michael Gulak, and Professor DJ, long-time supporter, keeping out for his project that's coming out. Been talking to him about that in Discord. You're all amazing. Thank you, everyone. I will see you next time. Bye-bye.